Hello everyone. So today topic is techniques for Turing machine construction. So basically we have four techniques. The very first is Turing machine with stationary head, then storage in the state, multiple track Turing machine, and finally the subroutines. So in this video we are going to discuss all these techniques one by one. So with the very first technique we start here, that is Turing machine with stationary head. Actually, when we define a Turing machine, we studied till now that a Turing machine, when makes a move from a state Q with the input alphabet A, or we can say the state tape symbol A, then we have a new tape symbol, and we will move our head in one direction. That direction can be either left or right. Now, when we are working on this variant of Turing machine, we say that we are having a stationary head. We are not moving either left or right. We are staying on the same position as we were before. So, illustrating this with an example, say we were on state Q0 and now after the move we have moved to Q1. So, if the input tape contains this particular symbol, then on making this move, this particular A is now changed to S, but we have not moved our head in either left or right direction. The head is stationary at this particular position now. Now, coming to the standard Turing machine variant, if we want to achieve this stationary head position, we can achieve it in two steps. So the first step is we will move the head into the right direction and will change the symbol. Now we'll simply make a move in the left direction without making any change to the tape symbol. So we will achieve the same result as we were having here. So this was the first technique of constructing the Turing machine. Coming to the next technique, it is storage in the state. Under this technique, we used to store the information within the state. So what we do, rather than having the state, we will now be having a pair of the state and the tape symbol. Okay, so what is this A? A is the tape symbol, and we are now going to store this tape symbol within our state. Okay, so now the machine is modified to that the states become Q cross tau. Tau is a tape symbol and Q is set of states. So any state can be combined with the any tape symbol. So we have now the combinations of the set of states and the set of tape symbol. Right? Coming to the third variant, we have multiple track Turing machine. Under this, we have multiple input tapes. Now, if we have multiple input tapes, we will also have multiple heads. Now, the only requirement here is that we previously provided just one tape symbol while making a move, but now since we have multiple tapes, if we have k tapes, we have to provide a k tuple of tape symbol, because on every tape there will be a move, so we have to move according to the k tape symbol. So if we say this is a two tape Turing machine, now we have B here, A here, and we are on the state Q0. Now after making the move, we have changed B to C and A to D, and we have moved to the left direction, and now we are on state Q1. So this can be depicted as we have the symbols B and A on the tape first. Now we have replaced the symbols with C and D, and we have moved to the left side, and from state Q0 we are now on state Q1. So the fourth technique is subroutine. Subroutine is same as we have in the normal programming language. So this works like that: when you have the main program, it is executing, and when there is a call for subroutine, the execution of main program stops here, and then the subroutine is called. Then the subroutine is executed. Once the subroutine is completely executed, we will return back to the main program to the point where we have stopped, and then this execution start right from there. Okay. So similar is with the Turing machine. Turing machine, when calls a subroutine, the subroutine executes. So when the Turing machine calls another Turing machine, the particular execution of the another Turing machine being called is executed. And when the execution of the subroutine Turing machine is done, there is a temporary halt, and then it will return back to the main Turing machine where the execution is completed. So this was about the lecture of techniques for Turing machine. Hope you have understood everything. Thank you so much.